Okay. So why did this beta particle, why is it going up?
Because it's negative.
So because the beta particle is so much lighter, it's going to turn a lot more than the one that's so much heavier, even though the one that's so much heavier has twice the charge. So it is twice as attracted to the other plate, but it can't overcome the fact that it's really, really large. All right, so gas-filled radiation detector. So we've got radiation. Enters, knocks, electron off, argon. Why is it? Whoa. What was that about? You all right there?
Stuff's just disappearing up there.
I have no idea. That is just peculiar. I can't get it to. I'm trying to erase it, and for some reason it's just not erasing today.
It's erasing
It's
back
erasing
the
other
line.
things. Time to restart your tablet.
Hmm. Okay. Radiation comes in, knocks an electron off the argon. The central wire inside of the device is very highly positively charged. So the electron goes to it. It hits the wire, it runs through the circuitry, it gets counted, and then it returns back to the can, and the can has the argon with a positive charge waiting for it to turn itself back into argon gas. All right, so I think the hardest part of this question is just reading it. You're at 25 meters and then you walk back 15 meters so that your new distance is 40 meters. So I've got the equation is intensity, and intensity is distance, and distance. Oops, distance. So what I need to do is, what's going to happen to the radiation level as I walk away from it? It's definitely going to go down. So what I'm going to do is I'm going to say that this intensity here, this x is the intensity I'm looking for. So I need an intensity number, obviously, for an answer with intensity units. So 120 millirem per hour. So there's my intensity unit. So what do I do with my two distance units to get a smaller intensity unit? I can't divide by both of them. The bigger one needs to go on the bottom. So in this case, I'm going to put 25 meters here and square this, and 40 meters here and square that, because that's going to cancel out my meter units, and it's going to give me an intensity number that's smaller than the intensity number that I started with. Well, what is this, like 40 something or other?
It's like 48.
Well, since I just did it, it's still on my calculator, so 2 sig figs. All right, so 47 millirem per hour. Okay, so that's the intensity if I didn't use any shielding, and this is gamma, and we said we're going to throw 4 inches of lead up. So every 2 inches of lead with gamma reduces the intensity to 1/10 of what it was before. So the first 2 inches of lead is going to reduce it from 47 to 0.47 or to 4.7, and then the other 2 inches of lead is going to reduce it to 0.47. So my actual intensity at this new distance with the shielding is 0.47 millirem per hour. And that's pretty much how anybody who has an operating nuclear power plant fixes everything. Like, okay, so the room is this big and these people are going to be just outside this room. This is the intensity that they would get if there was nothing there, and how much do I need to throw up to make sure that they don't get overexposed. Half-life? I don't know, say so its half-life is a time-based thing. So it's just the time needed for half of it to disappear, half of the mass to disappear. So I've got that many grams of cobalt-60, and the half-life is 5.27 years. How long does it take to reach 256 grams? Okay. How long? So I need a time here. So the time is equal to negative half-life divided by the natural log of 2 times the natural log of what I end with divided by what I started with. And so the half-life is 5.27 years divided by natural log of 2 times natural log of 256 divided by 2,084 grams. Grams, close. Somebody have a number here? 15.8 years. Okay, that looks good. How about this last question?
Conductor,
Yep.
Need movement of electrons.
voltage, magnetic field.
Conductor in a magnetic field and
Movement between the two.
what?
The movement between the two.
Are you kidding me? It's relative movement between the two. So a wire, a magnet, and relative motion between the two.